good to go again.
Okay. Hey, thanks for joining us again. This is Nick with Texas Steel Buildings, and today we're going to talk about some metal building basics. So we're going to get started with just common types of steel. This will help provide a good guideline for some of the common terms, and you'll see some of the differences into why some steel is used in certain locations or certain applications and other steel isn't. So your two most common types of steel are hot rolled and cold formed. You're hot rolled, so what we do here is we just heat up the steel. A lot of times it's scrap steel to some ridiculously high 1700, 2000 degrees Fahrenheit. You melt that steel and then form it either into a shape or into a flat sheet. Your common shapes, so you've got pipe and tube, and then rectangular and square tube, and then you've got a few additional shapes, your angle and channel. Wide flange beam is probably your most common shape, and that's because the wide flange beam does a good job of having a good strength to weight ratio. S shape, so that is very similar to a wide flange beam, but the flanges aren't as wide. And then you've got your wide flange T and your standard T, and those are just your wide flange beams that you cut in half. Cold form members, so with a cold form member, it's essentially your hot rolled steel that is rolled out into a flat sheet, and then you go through and process it again. So you've got a roll former, which is essentially just a big machine that's got wheels on it, and those wheels go through and bend the steel in a certain direction. So your two most common shapes for girts and purlins are going to be C and Z. You'll also see that C used a lot in metal studs. They'll go through and add some additional stiffeners as well so that you can use it in lighter gauges. Most of the times your cold form is going to be somewhere in like an 18 to a 12 gauge. Sometimes you'll see it a little lighter in like a 20 or 22 gauge. And then sometimes you will see it heavier in like an 11 or a 10 gauge. Your three common types of metal buildings. So these are the three common types of steel buildings. Now you've got your square tubing building, your cold form building, and your rigid frame building, which most people consider a rigid frame building a pre-engineered building. So your square tube building is just like it sounds. It's a building where your main structure is made out of square tubing. Most of the time those square tube columns and rafters, or the frames, will be about 4 foot on center, and you're really limited onto your widths, your lengths, your heights, because they produce these all in a factory where they're wanting to make the same thing over and over again. You really only have maybe every 4 foot in width, and same thing in length, maybe about every 4 foot that you can go through and customize it. The nice thing about square tube buildings, though, is that they are more affordable. A lot of them are sold with 29 gauge sheeting and trim too, which drives down the cost even further. Cold form building is a building that's a little more high end than your square tubing building. It's going to cost a little more. It's also a little more rigid per se, in that you end up with more weight of steel. So we just talked about those cold form members, your C's and Z's. Essentially what you're doing is you're putting some of them back to back or using deeper members in order for you to go through and create your rigid frames. These still have pretty good spans, so a lot of times you can get a 30 or 40 foot clear span with one, and your base spacing can be pretty good size too. So you can get, I would say most common is going to be like between a 10 and a 15 foot base spacing, but I've seen 20, 25 foot bays before. You just end up with pretty deep members. Your rigid frame, so most rigid frames are going to be made from either on a small building I-beam, and on a big building a tapered member or a built-up member, and that's just plate that we're going through and making our own custom I-beam with. So when you've got a rigid frame, a small building, I would say small is normally going to be less than about 40 or 50 foot wide, and then your big members are going to be anything like 50 foot wide and bigger. Those are where you'll typically see your tapered members. Base spacing most of the time is between 20 and 30 feet. An eave strut. So Greg will put up a cool picture because it's easier to explain with pictures than it is with words. But an eave strut is really just your last girt and your first purlin. So it gives you somewhere at that top corner of your building for you to attach your wall sheeting to, and then to attach your roof sheeting to. And it's shaped kind of like a weird shaped C. So it's got a longer leg on bottom, and then the height matches the height of your purlins, and then a shorter leg up top for you to attach that roof. All right. Cool thing about the eave strut, I don't know that it's cool. It's just a thing. So a thing about the eave strut is that that's generally what we're measuring the height of a pre-engineered building to. So in structural buildings, most of the time it's top of steel. In pre-engineered buildings, it's going to be the top of your eave. So you will have that additional 8 or 10 or 12 inches difference between the top of your steel and the top of your eave with bypass purlins. Wind bracing. So wind bracing is really just there to resist the forces that Mother Nature places on your building. You will have to resist those forces on each of your walls. So you'll have 4 walls that have wind bracing. That's not really a great way of saying it, but basically each wall has to have wind bracing. The type of wind bracing is really going to depend on what you plan on using the building for and whether or not you need to have a door in each one of those bays. So your most common types of bracing, there's 3, 4, maybe 5 different types of bracing. So X bracing is going to be your most common type, and we've got a slide here that goes over specifically X bracing in and of itself. But you are connecting the top and bottom corners of each of those columns, or if it's roof bracing, each of those rafters to help stiffen up that building in the weak direction of your frame. Your most common type for an affordable build is going to be cable or rod bracing. And then once you get into bigger buildings or higher end buildings or buildings that have higher loading, those are where you'll see angle bracing or sometimes even a wide flange T member. Portal frames. So that's a frame that is essentially like a rigid frame that goes through and connects 2 of your main frame members together. It does that so that you've got that open bay so that you can put a door in that bay. So if you don't have the space to devote an entire bay to X bracing, you can go through and put in a portal frame or a rigid frame, and that'll allow you to put a door or a window in each of your bays. Wind columns aren't super common. That's because they place a moment load on the foundation, which increases the amount of load that the foundation has to carry. There's not really a good way of doing that, which is why most engineers prefer to avoid them. And diaphragm bracing is the bracing that you get from sheeting. Again, I would say most engineers prefer not to account for diaphragm bracing, so it's like an icing on the cake. They don't want it to be the meat and potatoes of what's actually carrying that wind load. X bracing, most of this is what we already talked about. Cable, super affordable. Rod is a little more robust than cable while still being pretty affordable. And then once you get to angle and wide flange T, you get some beefiness, some heft. Is that everything? Meh. Look at us, Greg. Okay, there we go. We made it through all the slides. Thanks so much for joining us. And if you've got any additional questions, we can go through. I've got like 100 slide presentation. I don't know that anyone wants to sit through like our 3-hour new hire training, but I can go through and do that entire presentation. Or if you've got specific questions, go through and drop them down in the comments. Again, for the sake of Greg, please like, comment, and subscribe. He is fed on likes, comments, and subscribes. If we don't get him, he doesn't eat, and he's looking kind of lean. So please like, comment, and subscribe. Thanks.